In Chapter 8, we're going to explore a new topic, and that is functions of two variables. We're going to look at how to do some calculus things with these functions, but in our first section, 8.1, we're just going to try to understand what is a function of two variables and look at a few examples. So at this point in your math careers, you've dealt with functions in a lot of different forms, but almost all of these functions have been one input kind of functions, f of x. X is your input, y is your output, and we can do a bunch of stuff with that. However, in real life, many models and processes require multiple inputs. We're going to be looking at functions with two and even some with three variables, but really what we're going to be talking about applies to functions of any number of variables, which is a much more realistic concept. So first, let's look at an example, and that is a store sells both xylophones and yo-yos. We're going to let P stand for the profit, which is what we're going to be tracking. X is going to be the number of xylophones sold, and Y is going to be the number of yo-yos sold. The table here is going to describe the function of two variables, the profit function P of XY. Note that we have our inputs inside the parentheses, just like we had for functions of one variable. Now we just have multiple. Also note that in this table, these things on the outside of the table, these are our inputs, where our outputs are the things that are actually in the table. Now, if I gave you this table, I'm not saying that you wouldn't be able to understand it, and really we're trying to relate these functions of two variables, these highly abstract mathematical things, to something that you've probably seen before, and that is a table of values and how to read it. But this is a function of two variables. As with most complex mathematical things, we're not going to introduce a bunch of brand new stuff to deal with these functions, but we're going to try to think of them as two functions of one variable and then do calculus things on those individual functions. When we do that, we're going to call this a cross-section of the function of two variables. And those cross sections are going to be functions of one variable. So now let's look at this function in more detail. We're going to answer some questions about this function. First of all, let's answer how to find a function value. So first question, find P of 2050. So that is, what is the profit if 20 xylophones and 50 yo-yos are sold? So in our table, we're going to look at 20 xylophones, and we're going to look at 50 yo-yos, and then those meet together at our value that we're looking at, 400. And since this is in dollars, we're talking about a profit of $400. So now let's look at these things called cross sections. That is going to be B, C, and E are all going to be cross sections of this function. So the first one we're going to look at is, what is P of X0? That is, what happens if no yo-yos are sold? So we can think about these functions as businesses. A function of one variable is a business that sells one kind of item. It's a very simple business. Now, this is a more complex one, but we can think about it if, what if it were just a business that just sold xylophones and didn't sell yo-yos at all? So if this were the case, then what we're looking at is just this column. That is the wrong column, sorry. We're looking at just this row where we have 0 yo-yos sold. So we can describe that function as maybe just this table of values and think about it as x and f of x. We'll call it P of x. This is like a table of values maybe we're used to seeing in a algebra course. We're going to be looking at what happens if we sell 0, 10, 20, 30, 40, and 50 xylophones, and the profit will be given by those. And with that, we can even find a formula, an algebraic formula for that cross section. In this case, we know that if we go up 10 units, every 10 xylophones we sell, we are going to make a profit of $100. And that is the same all the way through. This is a very simple function that is linear. But now we know that we can write P of X as 10X. 10 is the slope. We could have gotten that by going 100 minus 0 over 10 minus 0, y2 minus y1 over x2 minus x1. And you can verify that on your own if you would like. But this cross section, this function of one variable, we're just going to describe as 10x. Now let's do the same thing for y. What happens if the opposite happens? There's no xylophones sold. And that is going to be this first column. X is 0. We can kind of see that we're plugging in x equals 0. We're seeing what we get. And again, we could think about a table of values. This time we're not thinking of x, we're thinking about y. And what happens to the profit in terms of y. So here again, we have 0, 10, 20, 30, 40, 50. And P of y is going to be 0, 40, 80, 120, 160, 200. So in this case, when we go plus 10 yo-yos, we are adding 40 each time. And that's consistent again. Again, this is a simplistic example that the cross section P of y is going to be linear for y. Again, you could find that 4 by going 40 minus 0 over 10 minus 0, finding the slope. So P of y is 4y. That is our cross section. And again, we could write these cross sections as the same thing as P of x 0. This is the same thing as P of 0 y. So now we can use that information in this simplistic example to find a formula for P of x, y. Since it is linear every single step of the way, we can write P of x, y is 10x plus 4y. And that is only because this is a linear function in both directions, but it's something that we could do here. Please do not think that you can always just find the simplistic cross-section of x0 and 0y and combine them, and that will give you a formula for P of xy. It is not that easy, but we're starting with an easy example here. Let's look at one more cross-section, that being the cross-section of 30y. In that case, we're saying x is 30. So that is going to be this column right here. And again, we could write this as a table of values. We have our 0, 10, 20, 30, 40, 50. And the values would be 300, 340, 380, 420, 460, 500, reading off that column. And this will give us a formula of the same 4y, but this time we're starting at 300. Another way to find that is we could have simply just done plugging in 30 to here. 30 times 10 is 300, and we get 300 plus 4y. So the purpose of this first example and the purpose of this first section is not to do things that are very crazy with functions of two variables. We're not doing any calculus right now here. We're just trying to understand what are these functions, how do we plug in values, what does it mean to have a cross section, and how do the two things relate. In the next video and the next example, we're going to look at some harder and more interesting functions of two variables. So sometimes we're not going to be given a table of values, but we'll just be given an algebraic expression. And as we go through this chapter, we're going to be focusing on this part a lot more. So our next example has to deal with money. The formula for the function m, which is equal to f of bt, two inputs b and t. M is the amount of money in a bank account t years after initial investment of b $1,000. If interest accrues at a rate of 4% per year compounded annually, we get that m, which is our function of two variables, can be written as b 1.04 to the t. So once again, there are two variables here that affect our output. It matters how much you put in at the beginning, that's b, and it matters how long you keep that money in the account, that being t. So here we're going to look at cross sections, but this time we're given the algebraic expression, which means that we can think about graphs of this function. So first we're going to look at cross sections with different initial investments. That's B equals $3,000, $8,000, and $20,000. Note that since B is given in thousands of dollars, this is the same as B equals 3, 8, and 20. So what these values represent, this red line here, is the function m is equal to 3, 1.04 to the t, a function of one variable. Same thing with this blue line, that is going to be m equals to 8, 1.04 to the t, and the green line, m is equal to 20, 1.04 to the t. And note that these starting values on the y-axis are what that value of b is representing, the 3, 8, and 20. So we're not given a table of values here, but rather an algebraic expression. But again, if you want to think about this complex function of two variables, you can break it up into parts where I'm just focusing on one variable. So why would you might want to do this? Well, let's say that you're trying to find what's the best way to make the most money for you, given what you want. You know that you might have three different options here. You know that you want to either invest $3,000, $8,000, or $20,000. And you want to look at those each individually and see what happens to the with different times, what's going to happen to the money. Or maybe you already know that you're going to invest just $3,000, so you can kind of just track just that function itself. Let's do the flip now, and let's do cross sections of just t. So here we're saying we're going to be fixed t equals 1, 5, and 10 years. So the first one is going to be our m is equal to b times 1.04 to the 1. That is, again, b times 1.04. That is a linear function. The second one will give us an m equals b 1.04 to the 5th. And again, that is also just a linear function. And the third one here will give us m equals b 1.04 to the 10. So why might this be useful? Maybe you know exactly how long you want to keep that investment in the account, and now you're trying to figure out how much money should you put in that account to make the right money. And why we're talking about this section is because usually the answer to that question is more difficult. You don't know how long you want to keep in the account, you don't know how much money you want to do, so you have to play with both variables at the same time. The hard part of that is you're not able to graph that function in two-dimensional space. And that's something that we're going to work on in this chapter is how do you even graph this function? How do you analyze this function? How do we know what might be the best amount of money or what's the best time to put in that account? We're going to be looking at mins and maxes of that function and do a lot of different things with that. So the next video, we're going to do some more practice problems, just trying to understand what are these functions. And then as we move on to next week, we're going to look at some more complex things, starting with contour diagrams.